So now we're talking about oil spill prevention control and countermeasure planning, oil SPCC. And it sounds like particularly with the move to above ground storage tanks, quite a few campuses are probably going to be subject to these rules. I will warn you now that there is potentially math involved in this program, but only basic addition and trying to see if you exceed storage threshold capacities. So don't worry too much, nothing like Dave's intricate calculations earlier. This is one of those programs that EHS folks may not have a lot to deal with directly. It may be managed primarily under your facilities department. But there is quite a bit more to this than the federal underground storage tank program in routine implementation of the program, ongoing training, and that sort of thing. So there's a little bit more to check with in this program. And one thing I want to point out before we get going, again, EPA has an excellent guidance document called Oil SPCC Guidance for Regional Inspectors. And it's actually designed for EPA SPCC inspectors. And it has a lot of clarification because sometimes these rules, it seems like there's a lot of gray areas. What exactly do they mean by this? What fits into this category? And I, again, have found this to be very helpful. It is a little bit dated because the oil SPCC rules change quite frequently, but the information that's there is very good, so you may find that useful. Okay, so oil SPCC regulatory overview. These rules are under the Clean Water Act and the Oil Pollution Prevention Act. The rules are at 40 CFR Part 112. This is a federal-only program. States do not get delegated authority for the oil SPCC rules, so all you have to worry about are the federal rules at Part 112. Again, the aim of this under Clean Water Act is to protect waters, is to keep oil from getting into navigable waters. This rule changes frequently. It underwent major amendments in 2002, again in December 2006, in February 2007, and there are currently proposed rule amendments out there right now. It's been sort of a controversial rule in that there's been a lot of room to clarify points, which is what EP has done in some of these revisions, and also to try to make it easier for smaller facilities to comply with some of the requirements. So that's a couple of reasons why we see constant revisions to the rule. Also, right now, the rules as they're written have to be completely complied with by July 1st, 2009. I would not be the least bit surprised if that date gets delayed again, because every 6 months to a year, EPA publishes a new deadline and they keep pushing it back. So right now that's the deadline, but it could very well change soon. So the applicability. These rules do not apply to everybody. You have to meet certain criteria to be covered under this program. First of all, if you are a non-transportation related facility involved in oil production, refining, storage, or well drilling. And campuses, of course, fall under the oil storage provision. If you store oil of any kind above the planning thresholds, and we'll talk about what SPCC regulates as an oil and what the thresholds are in just a moment, and if there's a reasonable expectation that a discharge in a harmful quantity could reach navigable waters. And a couple clarifications, very important here. Harmful quantity is not Exxon Valdez. Harmful quantity is a sheen. If you can see it, it's a harmful quantity, not much oil at all. Secondly, navigable waters. You don't have to have an ocean-going vessel, not even your own personal motorboat, for it to be a navigable water. A stream, a creek, a pond, a lake, any of these are considered navigable waters. So if you do exceed the thresholds, it's pretty hard to not be pulled into this rule. So when we're talking about the thresholds, there are two different potential thresholds that you might exceed that pull you into the rules. There's underground oil storage threshold and above ground, and they're different numbers. For the underground, if you store 42,000 gallons or more of oil in underground storage tanks, you exceed the threshold, you're pulled into the program. When you're figuring out that calculation, you do not include permanently closed tanks. So if you had one of those concreted tanks, you wouldn't count it. The above ground oil storage threshold is significantly less, 1,320 gallons. It doesn't take much to get to that number. When you're figuring out the 1,320 gallons, you include all bulk oil storage containers and operating equipment that has an oil storage capacity of 55 gallons or more. And again, permanently closed tanks don't count in your calculation. Now, wastewater treatment exemption, we talked about this just under the last program, but facilities that are used exclusively for wastewater treatment and not used to meet these requirements are not covered under this plan. And here we're talking about oil water separators, grease interceptors. They're not designed to store oil. That's not their function. It's a treatment process for oily wastewater running through them. The exception to this is if you mean an oil water separator to act as your secondary containment for some sort of bulk oil storage tank, then it is covered under this program and would be subject to all sorts of inspection requirements and that sort of thing. We typically wouldn't recommend that. And that would say you have a garage area where you're storing 55-gallon drums of oil and they need some secondary containment. If you say, well, the oil water separator in the floor drain is my secondary containment, then that oil water separator is now in the program, subject to the rules, needs to be inspected and everything else. The easier thing is to put those drums on a spill pallet or provide some other secondary containment for them. We'll talk more about that in a moment. But typically, if these are just being used as their function of wastewater treatment systems, they're not covered under the SPCC rules. Now, the definition of oil. For this program, just about any kind of petroleum product, any kind of oil is covered. You'll see fats, animal fats and grease, vegetable oils, and then here, any kind of oil, grease, petroleum, sludge, synthetic oils, mineral oils, any kind of oil. The thing that's different here that most programs don't regulate are the animal and vegetable oils. So this pulls in your kitchen grease, which most other programs do not. So that would be covered in this program if you store it in containers of 55 gallons or more. Another definition that's going to be key is a bulk storage container. This is one of the main regulated categories under this program. Any container used to store oil, and again, 55 gallons or more is the threshold. If you have a 30-gallon drum of oil, it's not regulated under this program, 55 and above. And it includes storage of oil prior to use, while being used, or prior to further distribution and commerce. Basically just anything you're storing for use or future use on your campus. Oil-filled electrical and operating equipment are not considered bulk storage containers. They are regulated under these rules if they have 55 gallons or more of oil, but they're regulated a little bit differently than a bulk storage container. And we're going to give you some examples of what bulk storage containers are right now so you have an idea. Bulk storage containers are ASTs, above ground storage tanks, USTs, underground storage tanks, supply tanks for emergency generators. Here's some typical examples. This is a typical above ground storage tank. A moment ago we saw a picture of those nice, lovely new tanks that a lot of you are getting on your campuses. Above ground storage tanks. This is someone who's asking about an integrally mounted belly tank on a generator. This base of the tank is actually, or pardon me, the base of the generator is actually the storage tank and holds the fuel for that tank. These are all bulk storage containers. More examples are kitchen grease dumpsters, like this fellow up here. Some of you may have those. And 55-gallon drums. Now this is any kind of 55-gallon drum that contains oil, whether it contains used oil or new oil. If you have new compressor oil, hydraulic oil, motor oil that you store in 55-gallon drums, it's regulated under this program if you have more than either of the above ground or underground threshold exceeded. So those were the bulk storage containers, things that you would normally think of: above ground, underground storage tanks, 55-gallon drums, things that are containing oil. Also, various electrical and operating equipment can be covered under these rules. Again, if it has 55 gallons or more of oil. Examples of electrical equipment are oil-filled transformers or switches. See an example of a transformer here. One thing to note is that not all transformers contain oil. Some transformers are dry. Your campus may or may not be able to tell you whether they contain oil or not. If they don't, you can try looking at the transformer. Sometimes on the plate it will tell you whether it contains mineral oil or how many gallons of oil may be in it, but that's not a guarantee. So hopefully the campus can tell you if they have transformers. Another point is that if the transformer is not owned by the campus, if it's owned by the local power company, technically it does not have to be covered under your plan. You don't have to count it as your capacity. It's not your piece of equipment that you're responsible for. The utilities should be managing that under their own SPCC rules. That is a debatable issue. Yeah, I know what you mean. A lot of facilities. Do all of you contract out your food services, or? There's.
But still have ways.
If I'm writing an SPCC plan, I would include that unless the campus was very adamant that they did not want to. I think that you have a contractual relationship with them, you're working with them. If there is a release of that kitchen grease, you're going to share in some liability there, and it's initially going to be your problem anyway, so you do want to make sure it's being properly managed. So I try to say include those, and share the responsibility as much as you can with that contractor who's operating it, as far as inspections that might need to be done of that and properly maintaining it. But I think it's a good idea to include it just for a little bit more control, because quite frankly, those kitchen grease dumpsters and things, where we have a lot of potential for spills. I mean, they're usually always nasty with grease dripping down the outsides of them, and people might be carrying 5-gallon pails or something and dumping into them. So that's a real potential area for a release that you want to be seen as properly managed. Where, while there's a potential that a transformer could release, it's a very rare occurrence because you're not routinely handling oil with that or doing anything with that. So I would recommend that you try to include it. If there's not a relationship that makes that work, you can make an argument against it. More operating equipment. A lot of hydraulic equipment could potentially be covered under the program. Hydraulic elevators, lifts, other sorts of equipment. Yes?
I just want to say from our experience, and it surprised me that those transformers and these lifts contain a lot more oil than you think.
They can contain hundreds of gallons. Yeah. Yes, you would be surprised. You think, oh, 55 gallons, no way.
Yeah, I wouldn't.
But that's not that big, and that has about 80 gallons in it.
Some transformers I recall, ours is 330, 400 gallons.
Yeah, easily. And so sometimes you may not have, some campuses may not even have tanks, or may have one small tank, but if you've got a couple big transformers, that's going to put you above the threshold anyway. So you have to make sure you look at all of these things and trying to determine whether you're subject to the program.
Subject to the field control.
Oil SPCC program, right. All of these things you have to look at in figuring out if you're at that 1,320 gallons. And again, only 55 gallons or more. So say this hydraulic elevator reservoir held 40 gallons, it doesn't count in your calculation, and it's not subject to the rules. Got that 55-gallon threshold.
Again, I just have my SPCC plan, but 2 years ago, guy came in, engineer came in the hours, and he recommended we put a secondary containment on our reservoir. And
Hold that thought for a moment, because we're going to talk about secondary containment and the different kinds of secondary containment requirements. There are 2 different secondary containment rules depending on whether you're talking about the bulk storage containers, which are the typical tanks and 55-gallon drums, or something like operating equipment. So we'll go over that in just a second.
Does recycling, like recycling oil count into calculate? Oil that's going to be
Universal waste, and then you're going to recycle it for, say, your automotive shop.
So yes, you're collecting used oil. Yes. If you've got it in a 55-gallon drum or a tank that's 55 gallons or more, it does. If you have it in 5-gallon pails, no.
You might only have 5 gallons at a certain time.
It's the capacity of the container, not how much is actually in it. Okay, so secondary containment. Here we go. This is what we were talking about. 2 different secondary containment provisions. The first is the general spill containment provision, which applies to all sources of oil at your facility. The next slide, we're going to talk about this a little bit more on what that means. And the second one is the secondary containment provision at 112.8C2, which is for bulk storage containers, which is a sized secondary containment. So let's talk about this general secondary containment provision first. This one is applicable to all areas of a facility with a potential for a discharge. So equipment, transfer areas, piping, everything is subject to this particular rule. And essentially what the general secondary containment rule says is that you have to be able to detect and deal with a release before it gets to navigable water. So if you've got a hydraulic elevator and it has a reservoir 55 gallons or more, and there's a floor drain 2 feet from it that goes to your sanitary sewer system, which goes to the POTW, which is going to discharge to a navigable water, then you have to meet the general secondary containment requirement. You have to have something in place to potentially prevent that release. Now, if there was no floor drain in the vicinity of the hydraulic oil reservoir, then the building would act as containment, because there's no place for that oil to go if there's no floor drain near it, unless there's an exterior door right near it that it could escape from. So you have to really look at each individual scenario to figure out whether it's going to meet that requirement. So the general secondary containment, it does not have to be a certain capacity if you're talking about this general secondary containment. Again, just preventing that, detecting and preventing that release from getting to water before you can deal with it. And again, all sorts of things you could use: dikes, berms, culverts, boom. Now, there's been a revision. This was one of the December 2006 revisions to the SPCC rule that instituted this new thing called qualified operational equipment. Because of the scenario where you have sometimes it's very difficult to try to do that. And I think the transformers are a good example. If you have a transformer just on a concrete slab in a parking area, a couple feet away you've got a catch basin, there's not a lot you can do to prevent a potential release from getting that catch basin. You're not going to build a big dike around that because you don't want water building up around your electrical transformer. That's not a safe scenario. So there's limited things you can do. Now, say your transformer was on a pad and then it's surrounded by a dike and it's filled with crushed stone. That's a good general secondary containment measure, because any oil that's released from that is very likely going to be seeping right into the ground and not traveling very far because of that crushed stone around there. So in most cases, that's going to be sufficient. But where you've got that one on the slab and then the drain right there, any oil is just going to run right to it. So it's really hard to do anything with that. So that's where this qualified operational equipment requirement helps folks. And what it says is if you have not had a release of oil from this kind of operational equipment, if you put certain criteria in place, you don't need to meet the general secondary containment requirement. What you have to do instead is develop an inspection and monitoring program for that operational equipment, add an oil spill contingency plan to your oil SPCC plan, and have a written commitment of resources to deal with any potential releases. So what it comes down to is you've got equipment like that, you commit to doing monthly or quarterly inspections of it, take a look at it, make sure it's intact and its integrity is good. And this oil spill contingency plan, what that is, it's very similar to an oil SPCC plan, but has a few more provisions, requires a few more details in certain areas. So if you already have an oil SPCC plan, it's very easy to incorporate these additional spill contingency plan requirements into it. So if you find yourself in a situation where you're having a hard time meeting the general secondary containment requirements, this is very helpful to you. Okay, so now the sized secondary containment requirement. And this is at 112.7c. And this applies to your bulk storage containers, your above ground tanks, your underground tanks, and your 55-gallon drums, your kitchen grease dumpsters. They have to have actual secondary containment that's going to hold the full contents of the largest single container and sufficient freeboard for precipitation if there's a chance you could get rain, or, well, not snow so much here, but if you could get rain inside it, you need to have a little extra room to account for that. So those are all of these things. They're covered in there, have to meet this secondary containment. So if you have a 55-gallon drum on a spill pallet, that spill pallet must be able to contain 55-gallon drums. 55 gallons. I've seen very short, small spill pallets that don't contain that much, so you need to make sure it has sufficient capacity. If you have a 275-gallon above-ground storage tank, whatever containment you have it in must contain at least 275 gallons. So just to back up again, because another one of the things, does anyone know if they have a loading or unloading rack? They're not common, but if you were to have a loading or unloading rack at your facility, it would be subject to this size secondary containment requirement too. And just to give you a little bit of a description here, it is not currently defined in the oil SPCC rule what loading or unloading rack is. It just mentions it in one of the regulations. This guidance document that I referred you to does give you some sort of guidelines as to what they would say a loading or unloading rack is if an inspector came to your facility. Equipment is permanent structure for loading or unloading a tank, truck, or tank car. It's comprised of piping assemblages, pumps, valves, loading arms, or similar devices. It's necessary to load or unload the trucks or the cars, and it has shut-off devices, overfill sensors, all of those sorts of things. If you have a simple fill port, or if you've got a simple fill pipe going to a tank, it's not a loading unloading rack. These are really at terminals. They're really pretty elaborate systems. but there is a potential that a large facility could have one of these. Actually, just very recently, October 2007, EPA proposed an official definition to be incorporated. In the Federal Register, this is the actual definition, which pretty much incorporates those points that we just went over. But this is still in the proposed rule stage. Eventually, they'll probably finalize it, and that will end up being the definition. Largest single compartment. This is important because if you remember that size secondary containment requirement states that you have to be able to contain the largest single compartment of whatever's in that containment plus sufficient freeboard. Where this can come into play is if you've got, say you have a big diked area and you've got 2 tanks in it, 500-gallon above ground tank and a 1,000-gallon tank. That diked area has to contain 1,000 gallons, the single largest container, because the theory is they're not all going to go at the same time. So let's be able to hold the capacity of the largest container. The exception to this is if you have manifolded tanks. If you have 2 or more tanks that are connected by piping that essentially act as a single tank because the flow from one just goes right into the others, then the secondary containment around them has to hold the capacity of all of the tanks, because there's a potential that if one breaks, if they're all connected, they're all going to release. Other than that, it's just the single largest container. Okay, so the kinds of sized secondary containment could really be any number of things. A double-walled tank, which we saw an example of in the last UST presentation, where it's essentially a tank within a tank. A steel or concrete dike, earthen berm, spill pallet for drums, just anything that's going to contain it. It could be as simple as you build a sealed concrete block wall around a tank in a basement. As long as it's going to hold the contents of the largest single container, you're set. Tank design and equipment. Similar to the UST rules, tanks under the federal SPCC rules have to meet certain design requirements. If you have a completely buried metallic tank, now this is metallic, not fiberglass reinforced plastic, installed after January 10th, 1974, it has to have corrosion protection and be regularly leak tested. Don't think anybody has this. It sounds like Uval tanks have been upgraded, but if you did have a single wall metallic tank, it has to meet these requirements. Buried portions of partially buried metallic tanks need corrosion protection for the part that's in contact with soil. And tanks have to be equipped with gauges and high-level alarms to prevent overfills and discharges. So now that we know what tanks have to look like, the secondary containment they needed to be provided with, what are some of the administrative rules that go along with this? First is an oil SPCC plan. You have to have a written document that's going to describe how you're going to manage those tanks and deal with any potential releases. Some of the basic things that are going to be described in the plan: all of your oil storage containers, everything that falls into it that we've just been discussing, oil handling and management practices, measures to prevent or control a spill, and measures to address a spill if it should occur. Because you want to plan in advance for anything. When you're in the middle of a spill, that's not when you want to ask who are we supposed to call, who's going to take care of what, where are the spill materials.
We have to have that plan now, not July of next year, right?
Well, the rule says you have to be in full compliance. Well, there are a couple different things. It depends upon when your facility became subject to the rules. If you were already subject to the rules in 1973 when they first came out, you are supposed to be in compliance by then. If you developed a new facility, newly became subject to them in the interim, depending upon when that happened, you're supposed to put your facility into compliance upon coming into operation. I'm not sure how you're going to handle this in your disclosure. Typically, when we do this, when we do our auditing, we'll write it up if we see that somebody doesn't have a plan, if they're not in compliance with any of these requirements, as violations that need to be addressed. Sometimes we'll have clients say, well, you know what, that's my deadline, July 1st, 2009, so I want to have until then to correct these. And I guess that will be up to however your agreement is set up and however it's handled. Okay, so a lot of information is contained in an oil SPCC plan if you have a good plan. It really should be a detailed document. I've reviewed dozens and dozens of different SPCC plans, and they really vary in how well written they are and the level of detail they have, the amount of information about your particular tank system. And I tell you, the more information it has, the more helpful it's going to be to you and to any regulator who needs to take a look at it. But some of the things you're going to describe in there are the physical layout of the facility, and you have to have a facility diagram that shows all of your oil storage containers. Talk a little bit more about that. Description of the total quantity of oil that could be discharged and the predicted direction of flow of any discharge. Details of your tank and secondary containment systems. Description of facility drainage, both your interior drainage, where do your floor drains go, and what is your stormwater drainage system? What sort of collection system do you have? Where does everything flow? Tank inspection integrity testing program needs to be established. Loading and unloading procedures, because again, oil deliveries, oil transfers are your biggest risk for a release. Procedures for maintaining tanks and ancillary equipment. Secondary containment discharge procedures, so that if you have, number one, if you have open outdoor secondary containment has a potential for precipitation to accumulate into it, you have to have written discharge procedures and logs for discharging that. Contact names and phone numbers for emergency response personnel and spill notification procedures, spill prevention and containment measures, a list of your response equipment, site security details, personnel training program description, record keeping, and you also have to keep records of all of your inspection, testing, and training. We'll talk about that a little bit more. Your SPCC plan, in most cases, we'll tell you the exception in a minute, needs to be certified by a registered professional engineer. And when they certify it, they're going to attest to these 5 different criteria. Don't have to read through those. The exception, though, again, this is another new rule that came out December 2007. Just like the qualified operational equipment where they sort of gave you a little bit of out with that general secondary containment requirement, EPA now instituted qualified facilities. You are a qualified facility if you store less than 10,000 gallons above ground and you have not had a reportable release of oil. What that means to you is that if you can meet these criteria, you could essentially self-certify your SPCC plan. You don't necessarily have to go to a registered PE. I caution you, if you do though, you have to attest to 8 different criteria if you are self-certifying your own SPCC plan. Among them, that you're familiar with the SPCC rule and you've prepared the plan in accordance with good industry practice. If you don't know a lot about that kind of thing, you're probably better off having a PE certify your plan for you. You also have to be able to meet all of the SPCC requirements. So if you're deviating from any of the rules, if you are, say, have qualified operational equipment that you're not meeting that general secondary containment requirement for, then at least that portion has to be certified by a PE. Any deviations need to be certified. So it is an option for some smaller facilities, but I wouldn't take it on lightly unless you feel very comfortable that you know what you're doing.
The EPA report oil spill, is there a time limit on that?
Yes, and we'll talk about what is a reportable spill toward the end of the presentation and go through all of that, the volumes and the reporting.
Is there a template out there for doing a SPCC plan?
I've not seen one. I mean, there are the regulations which describe what needs to be in there, but I think it's a more complicated undertaking than some might think. And you have to address all the requirements, but then again, develop and implement appropriate inspection and testing procedures for all of your containers. So you have to have some idea of what that appropriate procedure would be to do the plan. Unless I would say yes, unless I don't know anybody who has written one on their own, or they've tried it and then they've called and said, you know what, I don't think I want to do this, can you help us with this? So I say that the option is there, but be careful if you decide to undertake it.
And that's $6,000.
I'm sorry, it's what?
$6,000 for them to write it.
For who to write it?
The engineer to write it.
I guess it would depend on who you ask to write it. I mean, there's not, unless you have some agreement with the outside agency. They'll write it. Alex?
I'm gonna have a price.
Actually, we're looking at GIFA to possibly coordinate that effort for the system as a potential service to actually go out to somebody like Soil Materials or somebody of the like to basically be a contractor for that specific service, because we've recognized throughout the system that we have this need. There are several larger institutions that do not have an SPCC plan, and we know this. And so this is something they know too, and they're trying to work on this. And so it's something that we're trying to see if they can get us good pricing, then that way we don't, you know, at the individual institution, you're not taken to the cleaners on it.
Yeah, certainly if you're getting sort of a volume pricing for the whole system, it'll be better than every school individually trying to go out and have their own plan developed.
But that is just, at this point, is a potential. We're just trying to get that going so we can make this another value-added service that GFA provides. So we don't quite know how this is looking, because they've turned to us, how can we help your system even more? Because obviously there's the whole issue that we went through earlier this morning with the paperwork and the plans and the drawings, and so that's a separate issue of this. It makes sense for them to be involved in that because obviously the tanks are directly related to these SPCC plans.
So do you have I think I was going to ask your question. Go ahead.
So in the meantime, we should just get the records up and all the paperwork and not try to write our own?
No, you can, I mean, try to pursue getting, I would recommend get the engineer to certify your plan and write your plan, because that is the safer way for the institution.
And you don't know how long this other procedure may take, so if somebody knows they need a plan and they don't, they should pursue it rather than wait?
Yeah,
That's your
we're strictly
recommendation?
trying to do this to save the system money, more so than anything.
Consider the level of support we've received from you in the past, please.
That is factoring in, trust me.
What's the updating period? How frequently do you have to update this?
We're going to cover that in just a moment.
You can write the plan without being a PE, can't you? Just let you have.
If you wanted to undertake writing it yourself and then just finding a PE to certify it, you could do that if you could find someone willing to do that. A PE who certifies it is likely going to want to come to your facility, look at everything anyway. I don't know by the time they go through that how much of a cost savings you'll have, especially if you're a one-person show and you've got limited time, so you may need to balance that out. Because again, they're going to have to invest quite a bit just to review and certify it. So, okay. Alex.
Comment. If we can't have this working with GFA, it's not to say that maybe we get a state contract that's out there that you can use with one or two firms around the state. Because obviously it doesn't make sense for somebody in Savannah to go to North Georgia to do an SPCC plan, you know, if that's required. So, I mean, if we can strategically place these where they're convenient to the institutions, then that's something we'll entertain relatively soon, because it's something that needs to be out there for our institutions, because we do have that liability.
Okay. All right, so plan review requirements. How often do you have to review your plan? An oil SPCC plan has to be kept current. The regulations state that it must be formally reviewed at least every 5 years. Things change relatively quickly on campuses. New tanks come in, new generators are installed, 55-gallon drum locations get moved. So you're likely to going to have to actually do this more frequently. But if you do your review and you find that amendments are required, they need to be completed within 6 months. And any technical amendments, things such as a new tank, a change in secondary containment, new inspection procedures, need to be certified by a PE, again, unless you're going with that qualified facility route and doing it yourself. The facility diagram that we mentioned, there's very specific things that you need to make sure show up on your facility diagram. All of your ASTs, USTs, mobile containers, 55-gallon drums, kitchen grease containers, all need to be documented on the facility diagram as to where they are and what they contain. Oil-filled electrical and operating equipment, fill ports, and connective piping needs to be shown, oil transfer areas, and any loading and unloading racks. So for instance, if you've got a tank, your facility diagram should display where on your campus that tank is and label it as a 500-gallon diesel AST, whatever it is. You need to have that kind of information for your tanks. The plan should describe all of your transfer and delivery procedures. Don't need to read through this, but there are a lot of different scenarios. If you're getting deliveries of fuel, if you're getting kitchen grease or used oil picked up, all of those are transfer procedures that you want to have procedures in place so that both your folks know what they should do and the vendor is aware of what they should be doing and what you expect of them. Inspection and testing program. Bulk oil storage tanks, now we're not talking electrical and operating equipment, but bulk oil storage tanks need to have frequent visual inspections and regularly scheduled integrity or other means of testing. So for that frequent visual inspection, you need to be able to see the tank. Gets a little tricky if you've got a tank in a confined space, and then extra measures may be required. But you have to develop these written procedures. The rules don't say what the procedures has to be, how frequently you have to do these. That's really up to the PE to develop as appropriate for your campus and your oil storage facilities. But really, a good PE is going to base it on something, an industry standard. And when we write these plans, we do them either according to the Steel Tank Institute requirements for shop fabricated ASTs or the American Petroleum Institute for field-erected tanks. It should be based upon something rather than, you know, this just seems like a good idea to me. Here are some methods of integrity testing. Again, basically all of these are just designed to ensure that the thickness, the required thickness of the tank is still in existence and that the tank can contain pressure and its integrity is intact. Site security. The rules want to make sure that you've put in place measures to prevent unauthorized access to your facilities and damage from vandalism. So what they ask for are fencing oil storage facilities, ensuring flow drains and discharge valves are secured and in a closed position when not in use, locking up starter controls to prevent access to unauthorized folks, capping and blank flanging loading and unloading connections when they're not in use, and providing facility lighting. Now you're looking at some of these things saying, well, my campus is not fenced. And some of these things can be really hard to do because a campus is open to the public. You can't necessarily restrict who's coming and going and where they're going. So some of the things you can do to help accommodate for some of these things you can't meet are locking rooms and enclosures where tanks and drums are. If you've got the generator tanks, keeping those casings locked, keeping transformer cases locked. If you have a fill port that's very accessible, you might consider putting a locking cap on the fill port. Lighting is an easy thing to do. Make sure that all of your oil storage facilities are well lit. And then fuel dispensers, and probably everybody has this. I doubt anybody has an unsecured fuel dispenser right now, especially with gas prices. But you have some sort of card reader or lockout system for all of those pumps. It has to be reasonably secure. Is that a loading dock?
Near a loading dock, it's back by the lake.
Okay, and what you do is you just put reasonable measures in place. You say we've got good lighting in place, we have campus security that does periodic rounds, people who work in the area are checking it on a routine basis. So for that kind of thing, you just try to make a reasonable accommodation.
3 o'clock in the morning, it's unattended. I mean, there's police on campus and there's lighting, but there's no staff on site.
Right. And I think people realize that, and there's sort of this reasonableness to dealing with that. I mean, if it's something you feel is an actual threat, what is it actually contained in?
It is in a large semi-portable container that is secured.
Okay, so nobody can get into the container.
Depends on how badly they want to cause business.
And I guess, yeah, and I guess it's, I mean, if somebody wants badly enough, they're going to break into a building or break a lock. I mean, there's only so much you can do to prevent vandalism. I think it's just being reasonable. And if you've got that secured and it's in a well-lit area, I think you've done what you need to take care of that security. So training. There is a training requirement in this program. All oil handling personnel have to have initial oil SPCC training. And anyone who has an oil handling role really should not work in an unsupervised capacity with oil containers until they've had it. Now, what is an oil handling personnel? It's anyone who is dispensing from or filling any of your tanks or containers, including kitchen grease. It's anyone who is maintaining the tanks, doing inspections of the tanks, anyone who's going to be responsible for responding to a release, who has a responsibility written into your oil SPCC plan. All of these folks should have oil SPCC training. It is a one-time training requirement. However, there is a requirement that you hold discharge prevention briefings at least annually. they're, not the exact same requirement as a training, but you do have to get all those same folks together at least once a year and go over any changes that may have been implemented to the plan, any different changes in procedures or new oil storage facilities. Were there any known discharges? How was it handled? Was it handled properly? All of those sort of things are what you would do in that annual briefing. You can do it as long as you are comfortable going through the plan and describing the oil SPCC rules and the procedures that you have in place, then you can do that. There's no requirement for how the training has to be conducted or who can be a trainer. If you're including them in your plan, they should have training as well. And it can be sort of, to some degree, function specific. If all they're dealing with is that kitchen grease dumpster, all they need to know is about what pertains to that, and that's really the best way to do it. Now, your facilities people, they're going to have the whole training because they're probably dealing with many different things. EHS people should have the whole training. But if all they're taking is, that pile of kitchen grease or whatever, dumping it in there, then they need to know exactly what they need to do related to their role. And if there is a release, who do they call? How do they handle it? Do they have a small spill kit here that they can take some preventive measures with? Absolutely. Anytime you do training, anytime there's a training requirement, assume it's a documented training, and this is too. And have them sign off, have it dated so you can see the date it was there and everybody that attended. Because you do have to keep records, all of these records, for 3 years. So moving on, record keeping, we just spoke about this briefly a moment ago, but any inspection, testing, and training records you need to maintain for at least 3 years. Things to look for during an audit. Confirm that all bulk oil storage tanks and equipment are included in the plan. Sometimes people don't know they need to include 55-gallon drums or that they need to include electrical transformers if they're oil filled. So make sure all the applicable things are included. Make sure it's up to date. Maybe a tank got added 6 months ago and they didn't update their plan yet. Review the plan using the checklist. In the standard auditing procedure that you have, we have a couple of checklists. One for is auditing the SPCC program in general, and the other is for reviewing a written SPCC plan to make sure that it has the requirements that are in place. So we've got 2 different checklists for your use. Inspect the oil storage facilities for conformance with the plan. Do they have all the secondary containment they need? So when you're doing this, you're not only looking at is the facility in compliance with the oil SPCC regulations and is the plan cover everything it needs to, but is the facility implementing the plan? If the plan says that they're going to be doing monthly inspections, are they doing those monthly inspections? Do they have records to prove it? Are all of the containers covered in those monthly inspections? Again, people forget 55-gallon drums a lot, but if your plan says that you do monthly inspections of bulk oil storage containers, that includes your grease dumpster and your 55-gallon drums, as well as your above-ground storage tanks. Make sure that all of the required records are available, again, going back 3 years. Post-1974 metallic USTs need to have corrosion protection. They've talked about the means to prevent discharges and that they must have either a gauge or an overfill alarm. Confirm the containers meet all the requirements, and talk to the folks who have oil handling responsibilities and make sure that they seem like they have had training and know what they're doing. I was inspecting a facility last month, reviewing the monthly inspection records of the tanks, and somebody had written across the form, "I've not had training, I can't do this inspection." And somebody just filed that away with all the other inspections. So, watch for things like that and make sure that people who have responsibilities know what they are. I think that's it. But what I want to do is just go over, we talked a lot about the rules and the requirements and what you need to have, but I'd like to go through, I think, some more practical, okay, now you're going out to audit this, what do you do with this? And I'm going to talk about the underground storage tank program and the SPCC program almost as if they were one, because you're going to prepare for them similarly. And if you're auditing one, you will be auditing the other, because it doesn't make sense for somebody to look at this UST and somebody else to look at this other one because they're subject to different rules. The first thing I recommend, if you have the SPCC program, it's been assigned to you, get a copy of the plan in advance if the campus has one. It's going to be a relatively lengthy document. There are going to be a lot of requirements that you have to check for, and you really can't be well prepared if you haven't read that before you go, because you need to check for it being implemented on campus. And if you haven't read that, you can't audit it. So that means when you get there, you're going to sit down in a room for a couple of hours reading through this, when your time on campus could be better spent actually inspecting and working and talking with people and interviewing. So if at all possible, I always recommend you get a copy of that in advance and review it. I think that the key to this, and probably any auditing, is organization and preparation. If you haven't done this a lot, it's a lot of different things to keep track of, a lot of things going through your mind. The more you can get yourself ready in advance, you're going to feel so much more comfortable when you're actually there. So read the plan. Set yourself up with something in advance so you know what you want to do. A lot of times in the oil SPCC plans, they're going to have a table that lists out all of the various oil storage containers. I always take those out, make copies of them, and put them in a notebook and take them with me. And on that table, I'm going to write down, first of all, is there anything that seems strange after reading this that I know I want to check on? Something that doesn't make sense, a discrepancy in the plan, maybe the text says something and this table says something else and I need to figure out what's real. I know that this is this kind of tank, so it should have this equipment. Let's make sure that it does. So if it's got a table, that's a really great sort of cheat sheet to take out with you and use. If it doesn't have some sort of table, make a list of what tanks you know are there that you need to look at. I am a big fan of the 3-ring binder when I audit, because I can take with me whatever I want. It's all going to be attached in here. I don't have to worry about loose papers flying all over. And what I usually take is, blank note paper for taking notes, a photo log if you want to take photos, so you can, photo number 1 was this, photo number 2 was this, because later on you may not remember what that picture was of. And then any checklists or references you want. And you can have that all there with you while you're out. You can have a tab so you can find it easily. So that's usually how I get ready. If you have the SPCC plan, you're also going to take a copy of the facility diagram with you. That's going to be your map to find all the various containers and tanks that you need to look at. You have to confirm that it's accurate. Once you get there, you're going to sit down with the folks and you're going to ask all of your preliminary questions. If you've already read the plan, you may have some initial questions you want to ask them. You're also going to find out where the inspection and testing records are, where the training records are, all of those things that you're going to need to see. They may be in one central location, or they may say, well, the boiler plant has their inspection records, this area has their own inspection records, so try to find out where those things are so you know where you need to find them. How you go about inspecting the tanks, the ideal way is you just go with the geographic flow so that you're not going this side of campus and then over here and then back here. That's not always possible because you may need to accommodate scheduling. Not always, but sometimes you're going to need very knowledgeable people with you. For instance, when you go to a boiler plant, they typically have more complex tank systems. So you're going to want to have somebody who works with those tanks who can tell you about the monitoring system and how they maintain it, what do they do with it, what are the delivery procedures that they follow. Every generator tank, you may not necessarily need somebody there, but that's the sort of thing you need to consider. You may not, at a very large facility, you may not look at every tank. Very large facilities can have dozens of tanks. So it really depends. If you have a small facility, they have 5, 6, 7, 10 tanks, of course you're going to see them all. But what you may look at is similar to doing the RCRA program and you've got a few hundred labs, you do a representative sampling, you may have to do something like that with tanks if you have a very large facility. The other thing I tell people to do is take your time. I know that when I first started auditing, I was always very nervous because you would have 1 or 2 escorts with you and 1 or 2 people from the facility, the area that you were actually auditing, and I felt like I had to constantly be moving. I was wasting everybody's time. But take your time. Look through your notes if you're at a tank, if you're at a container, and make sure you're reviewing everything you want to for that particular piece of equipment. People can wait a couple of minutes. They expect you to be inspecting and doing what you need to do. So feel comfortable taking that time and going through it. It'll be a lot more burdensome to people if you forgot to check something and you have to come back tomorrow or something like that. So don't worry about that. The other thing is if you're doing tanks, you have to dress appropriately because you could be climbing up on tanks, you could be going into nasty, dirty basements, crawl spaces, boiler rooms. climbing up ladders. You don't know where you're going to have to go. It could be raining, it could be muddy. So make sure that you dress appropriately to be able to handle all of those activities. And a final word is safety. Tanks can sometimes be in confined spaces, and I'm sure that you are not meant to go into a confined space to look at a tank. So if a tank is in a vault or some other space, look at it from outside and don't go inside. And I think that's about all. Are there any more questions on SPCC or USTs? At least every 5 years. But it's rare that you won't make a change in 5-year time period that's going to warrant it being updated before that, I would think.
That's 6 months from when you find out that there's an alteration.
To actually
Out of the tank or something.
to actually get the change into the plan, right?